Hello Legacy Sabers, Marsh here. So today we're going to solve equations, inequalities, and literal equations. Today you're probably going to want your notes out, pen or a pencil, and you may need a calculator today. Some learning targets for today. I can solve multi-step linear equations and inequalities. I can solve compound linear inequalities. I can sketch solutions to an inequality on a number line. Then I can also isolate a specific variable using mathematical operations. So first, guys, we need to talk about what does it mean to solve. Well, when you are solving something, it means you're going to find the solution or solutions to an equation. So basically, it's when you find the x equals blah. Basically, you're going to find a value that makes the statement true. So when you're solving, you have to have an equal sign. That is the biggest thing, most important thing of when you are solving is there needs to be an equal sign present. So let's look at an equation. So let's solve this following equation. So I have 3 times the quantity of x plus 4 equals negative 2 times the quantity x minus 5. So what I want to do is get x alone. So I'm going to first distribute this 3 in. So I will have 3x plus 3 times 4, 12. I'll do the same thing on this side. So I'll have negative 2 times x, that's negative 2x, and negative 2 times negative 5, which is a positive 10. Now, I need to get the x's all onto one side and the just numbers on the other side. So I'm going to move this negative 2x to this side. So I'm going to use its opposite, use the opposite operation, or the inverse operation. Right now it's subtracted. I'm going to add it to both sides. So 3x plus 2x, I get 5x plus 12 equals negative 2x plus 2x, that is 0, so that's going to cancel off. And then I'll have 10 there yet. Let's get this 12 to the other side, so I'm going to use my inverse operation, subtract, and get 5x equals 10 minus 12, which is negative 2. Finally, I got to undo this multiplication, right? Because this is 5 times x. So let's divide by 5. And I'm going to get x equals negative 2/5. And I'm going to leave it as the fraction due to the fact it's more precise as a fraction. Now, what about solving an inequality? Just some things to remember. If you divide or multiply by a negative, remember you got to flip the flipping sign. You got to flip the inequality sign. So if it's a greater than, you got to make it a less than. Okay, something to make sure, keep in mind, maybe star this in your notebook or something, because I find this is where a lot of students mess up. Then you're also going to sketch the solutions on a number line. Remember, there's open circles and there's closed circles. Open circles is when you have a less than or a greater than symbol. Closed were with less than or equal to or greater than or equal to. So they have to have an equal to sign to be a closed circle on your graph. And we'll go over a couple of examples. And then compound inequalities, we'll look at those as well. Those are when you have 2 inequalities together, so either an and or an or. We'll look at both kinds. Let's look at one here. So I got 10 is less than or equal to 6 minus 4x. So, just like when I was solving my equation, you want to get your numbers to one side, leave the x's on their own other side. So I'm going to get this 6 to the other side, so I'm going to subtract it. So I have 10 minus 6, 4, bring down my inequality sign, less than. 6 minus 6 is gone, so I'm left with negative 4x. Looks like we need to divide now by negative 4. Now, there should be a little red light in the back of your head saying, warning, 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 because you just divided by a negative, right? And if you divide by a negative or multiply in an inequality, flip the flipping sign. So now I have 4 divided by negative 4, negative 1, flip the sign. Now it's not a less than, it is a greater than symbol. If you do not do that, guys, you will get the wrong side of solutions, because inequalities have multiple solutions to them. They have a range. Now, if you do not flip the sign, you will get the other side of solutions that will not work in the original inequality. That is why we need to flip the sign. And then I'll have x over here. Now, I need to graph this on my number line. So, very first thing I always do is I put right in the middle, I put -1 right there, and then I figure out what kind of dot is at -1. Is it going to be a closed dot or an open dot? So I look here, it is a greater than or equal to, so thus it's going to be a closed dot. Now, here's how I remember that. 2 pieces to the inequality sign, right? 2 pieces to my circle. Gotta draw it and fill it in. Okay? Now, which way are we going to go? -1 has to be greater than or equal to x. So that means the x's have to be less than or equal to -1, right? Basically, all I did is just flipped around this inequality. So my x's need to be less than -1. Which side? So if I would mark some negative, that would be -2 over there and 0 over there. So which way is going to work? Are -2 less than -1 or 0 less than -1? Well, -2 is, right? So I'm going to scribble on that side of the dot, or if you want to just put an arrow, whichever one works for you. Now, what about a compound inequality? This is an and version. Just keep that in mind. Ands look like they have 2 inequalities slapped together. Now, that's all that it is. You could technically separate them and solve them separately. That's all fine. I like to just solve them together in one big problem, if you want to consider it that. So what I'm first going to do, let's not think about this side over here. Let's kind of forget about this is present. And now I'd have 3x minus 1 is less than or equal to 3. You would add 1, right, to get the 3x alone. Well, since I'm adding 1 over here, I'm going to add 1 over here. So basically what you're doing is working on 2 problems at the exact same time. Now, I will have -12 plus 1, that is -11. 3x in the middle, and 4 on this side. Looks like I need to divide by 3, but now I'm going to divide by 3 on all sides. 1, 2, and 3 sides. So now I have for an answer -11/3 less than x less than or equal to 4/3. So now what do I need to do? I need to write twice here. I need to write -11/3 and 4/3. What kind of dots? Well, this is just a less than, despite what this random line all of a sudden that appeared. This is just a less than, so this needs to be an open dot. 4/3 is equal to, so this needs to be closed over on this side. Now, let's read from the variable. X needs to be greater than -11/3. Let's repeat that. X needs to be greater than -11/3. So it needs to be greater than, so it looks like it needs to go this way, right? Now, x has to be less than 4/3. That side. So it looks like I'm going to be shading the inside. Now, something to keep in mind. And inequalities, these kind. They will usually, 98% of the time, they will shade on the inside because the way that the inequality is set up. Usually the solutions to an and inequality are located in between the 2 numbers you found. Now, is that an always? No. Sometimes you will find that they will not turn out that way and they'll both go shoot off to the same direction. Just be in mind that usually they will meet in the middle. Now let's try an or inequality. First things first, work on one problem, solve it, and then do the same thing on the second one. So I'm going to solve this one here. So I got 5 minus 5, 9x less than or equal to 9, divide by -9. Oh, I divided by a negative. Let's make sure we flip the sign. So I'm going to get x is greater than or equal to -1. Now, before I graph that, I'm going to solve this side of my OR inequality. 17 divided by -4. Whoop, flip the sign because I divided by -4. So x is less than -5. Now let's graph this. So I got -5 over here, -1 going over here, right? Because -5 is smaller than -1. -5 looks like he gets an open dot, not equal to. -1 does have a closed dot. X needs to be greater than -1. So which side is greater than? Is -5 greater than, or technically like 0 over here? Well, it would be 0, right? And x needs to be less than -5, less than, it's got to go this way. Now, OR inequalities, guys, they usually will go away from one another. Just like the ands, it's about a 98% chance that it will do such. However, there are some that will turn into and inequalities. But be pretty mindful that they usually will go away from one another when you graph them. Now, second part of this video, what is a literal equation? Well, a literal equation is basically an equation that has more than one variable. You see these all the time in math, last year, geometry. You also see this a lot in science classes. So I got my ideal gas laws, and they have a whole bunch of random variables, and they all have to plug in. Geometry, whenever you were doing your areas and your volume, those always had different variables. Now, what if you don't have equation or values for each one of those equations? Well, ultimately what you can do is solve for a variable. So on this one, I am told I need to solve for x. Now you're probably saying, hold up, there's a b and there's a y, I don't know what to do. All you need to do is treat it like they are numbers. So what if b would have been a 5? How would you have solved for that? How would you have gotten x alone? Well, you would have subtracted the 5, right? So let's just do that. Let's just subtract the b. Now you're probably like, well, what's y minus b? Well, y minus b is just y minus b. Sometimes it's just as simple as writing what minus what. B's are going to cancel off. Now, how do I remove this 3/4? Technically, it'd be dividing, right? Because it's 3/4 times x, but we're smarter than that. We're not going to divide by 3/4. We are going to multiply by 4/3. Because remember, dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to multiply both sides by 4/3. So then I'm going to get a 1x over on this side. This side, though, this is 4/3 times all of this. Not just 4/3 times y. If you would have written it like this, that would not be right. Because this 4/3 is multiplied by the entire side. So I need to write my equation for the end like this. 4/3 times the quantity of y minus b. You could also do 4/3 y minus 4/3 b if you wish. That would be distributing, which you would not have to in my case. Alright, now let's try solving for r. This is a perimeter. It looks like it's perimeter of some nature. So we got 2 pi r plus 2x. So we need to solve for r. We need r alone. So I'm going to box r so I know kind of what I'm looking for, right? So first things first, I'm not going to touch anything here because there's some division right here. But I do have something that I need to kick to the other side. So this is like that plus 5 again. So let's subtract 2x to the other side. Left side now, I'm going to have p minus 2x equals 2 pi r. Now we're still just solving for r, right? So let's divide by, well, technically I need to divide by 2 and pi, right? Take it all at one shot. Divide by 2 pi, all of it. Just take it all, okay? Divide by 2 pi over here. So now on the left side, I have p minus 2x all divided by 2 pi, and this is equal to r, what I want it to be equal to. Now you're probably saying, that left-hand side, Marsh, it is gross. It looks, no, it's bad. Leave it. Technically, if I had a value for p and I had a value for x, it'd be a very simple equation to be able to find my r. Yes, it looks kind of icky, but that is okay. There is no other way to simplify that. You could make them into their own fractions, but then it's going to look even more messy. So just leave it as that. Let's try the last problem here. So I have to solve for p. Whoa. There are 2 p's. Okay, let's get further here before we start to freak out that we have double p's. So, very first thing, you see how these both have a p. Let's get this t to the other side. So I'm going to add t. So I have r plus t equals pt plus ps. Now, how on earth can I get only one p in this equation? I have 2 p's. What can I do? You know, I bet factoring would work. Greatest common factor. If there is the same number multiplied on both, I can factor it out. Or if you basically want to consider it, I can do the inverse of the distributive property. So basically, I can do this. I can yank the p out of both of those. Now, if I'd pull it out, what did I actually multiply the p into? Well, I multiplied it into t plus s, right? Because if I would redistribute this p in, I would get pt plus ps. Exactly what I had before. Now, let's solve for p. Notice, guys, I now have 1 p. Yay! I can solve for p now. So I'm going to divide by t plus s, the quantity t plus s. Just like that. So now I have r plus t divided by t plus s, I'm going to put parentheses around that, equals good old p. And with a little bit of factoring and a little bit of can-do knowledge, we were able to get p alone. And that's the end of this video. See you later, Sabers.